Okay, hello everyone. In this video, I want to talk about the chemical properties of acids. Okay, so there are four basic properties of acid, and I'm going to discuss them briefly. The first chemical properties of acid is reaction with metal. Okay, the second property is reaction with bases. The third property is reaction with trioxocarbonates. Okay, and that is it, but we can add one more reaction with trioxosulfates. Okay, so these are the basic properties of acids. Now, in reacting with metals, generally acids react with metals to form salts and liberate hydrogen. So the most important aspect of this is that hydrogen is produced, hydrogen gas is released. For example, if I have H2SO4, for example, plus zinc is a metal. This reaction is usually a displacement reaction where zinc will displace hydrogen to become zinc sulfate plus hydrogen gas will be released. Now please, I'd like you to take note here that zinc, 1 mole of zinc can displace 2 moles of hydrogen. And the reason is because of their valency. The valency of zinc is 2 plus, the oxidation number. And the oxidation number of hydrogen is plus. So you need 1 mole of zinc can displace 2 of hydrogen since their valencies are this way. In the same way, if I have HCl plus, let's say, aluminium, aluminium can displace 3. So I'll have to put 3 by the side here. And I'm going to get aluminium chloride, then plus 3 molecules of hydrogen, which I can write as this 3/2 H2. Now, hydrogen must always be written as H2. Hydrogen gas is always written as H2. Okay, the reason I wrote 3/2 by the side is so that 3/2 times 2 can make it 3 moles, so that hydrogen can be balanced. Another way you can write this, you can multiply this by the fraction here, the denominator, and we are going to get 6HCl plus, that's 2 times 3, this is 2Al, giving us 2AlCl3, then plus 3H2, because 2 times 3/2 cancels out and we are left with 3. Okay, these are just ways to balance. You can look out for one of my videos on how to balance equations. Okay, so that is it for that one. Let's see more examples. Let's say you have H2CO3. Okay, no, let's use CH3COOH. This is ethanoic acid plus sodium. Of course, sodium can only displace 1 hydrogen because the valency is plus, it's just 1. So we are going to get CH3COONA. Then plus hydrogen is H2, but to make it 1 mole, we need to put half here so that it can be 1 mole to balance the equation. Okay, so this is very, very important. And don't forget that you can also make this formula or rearrange this formula by multiplying by this denominator, which is 2. So we are going to get 2CH3COOH plus 2Na, giving me 2CH3COONA, then plus H2. Okay, so that is how that one goes. Now this is how it goes. So the next is to see how to the next type of properties, which is reaction with bases. So we say that acid reacts with bases to form salt and water. This type of reaction is called neutralization reaction. But before I continue, I want to say something up here very briefly, is that an acid HNO3, we don't use acid for this reaction because this acid is a very strong oxidizing agent. it has strong oxidizing property. Okay, and what that means is that in many occasions when it reacts with metals, it does not form hydrogen, it goes ahead to form water, you know, because of its oxidizing property. That's an exam question, so you can take note of that. So even though we say that acids react with metals to form salt and liberate hydrogen gas, but HNO3 seems to be an exception here, and the simple reason is because it has high oxidizing property. It can actually, instead of hydrogen being formed, water will be formed, and that is not that does not make it resemble other acids. Then also, HNO3 is very passive when it's reacting with aluminium especially. And the reason is because it forms a protective covering. Now, it only reacts with the surface of aluminium, forming a protective oxide, but prevents the rest of aluminium from reacting. So, on the surface, you have a protective oxide, but the rest of aluminium does not react. So, generally, we say that aluminium is very passive to HNO3. Okay, that's something I would like us to remember. So we come to acid plus base giving us salt plus water. Now an example of an acid is hydrogen chloride. An example of a base is sodium hydroxide. You can look out um, my other video for how to identify acid and bases. So sodium here, usually hydrogen and the summary of this reaction is that hydrogen ion will react with OH ion to form water. That's the summary of this reaction. So that means the number of hydrogen ion and the number of OH ion should be equal if you must balance this equation. So in this case now, this is already good. So I can say sodium chloride then plus hydrogen and OH will combine to now give us water, H2O. Now let's see another one. Let's say H2SO4 then plus, let me use zinc hydroxide. In this case here, zinc hydroxide, the same thing, the number of hydrogens and OH are equal, so I can simply have zinc sulfate. Zinc can combine with sulfate, then hydrogen and OH will give me water, but this time 2 molecules of water since they are 2 each. Then in a case where we have something like HCl plus calcium hydroxide, in this case here, you can see that the hydroxide we have 2, but hydrogen is just 1. So we can balance it by making this 2. Okay, that means I'm going to have calcium chloride written like this. It works. Then plus 2 hydrogen plus 2 OH now gives us 2 molecules of water. Now that is very, very important. Okay. Then also bases are also they are also hydroxides of non-metals. They are also oxides of metals. So metallic oxides are bases. So I can have something like this: H2SO4 plus zinc oxide. Zinc oxide is a base. So you can have H2. This is already H2O. Then we have zinc sulfate. It's a very simple reaction to balance. Then plus water this way. Now that's very, very important for us to note. Okay, so that is it for the second property of acid. An acid will react with base to form salt and water. And I showed you how to balance a reaction like that. Now the third type of reaction is with trioxocarbonates. Now acids react with trioxocarbonates. We call them trioxocarbonates, okay, to form salt, water, and carbon dioxide. Okay, so acids and trioxocarbonates react to form salt, water, and carbon dioxide. So if I take an acid like, let me say H2SO4, then plus a trioxocarbonate like calcium carbonate, this works, okay? Don't forget that, well, another way you can present these reactions, the ionic reactions. Ionically, you can say 2 hydrogen ion. This is SO4 2 minus plus Ca2 plus. Then this is CO3 2 minus. This is another way if you think of balancing it. So when they combine, you are going to have calcium will meet with sulfate to become Ca2 plus and SO4 2 minus. Then hydrogen will meet with this to become 2H plus, then CO3 2 minus. So you can see that the final product is going to be calcium sulfate. Hydrogen and carbonate is very unstable. It's supposed to be H2CO3, but that's very unstable. Will decompose to give us water and CO2. So whenever an acid reacts with a triazocarbonate, water and CO2 will definitely be formed. Okay, that's very important. Look at this again. HCl plus Na2CO3. This is 2 here because of sodium. You can say calcium is one calcium can displace two hydrogens. Okay, so you have two hydrogen chloride here. You have Na2 this. In this you are going to get sodium chloride, then plus water, then plus CO2. That is very important for us to note. Very, very important. Okay, so that leads us to the fourth one. Now, in the fourth one is reaction with triazosulfate. Now, this is the symbol for triazosulfate. So, in this case here, when an acid reacts with a triazosulfate, we are going to get salt plus water, then plus SO2. So I'm just one example here. Let's say you have H2SO4 plus triazosulfate like Na2SO3. You're going to get Na2SO4 then plus H2O plus SO2. Don't forget H2O and SO3 would have given us this, but this is unstable, so we decompose to H2O and SO2. Now this is very important for us to know. So that is it for the chemical properties of an acid. Thank you very much.